Good morning. I am Dr. Niti Maheshwari, Assistant Professor, Applied Science and Humanities Department, Ajay Kumar Garg Engineering College, Ghaziabad. Now today I will be discussing in module 4 the next part, that is fuels. Now in this heading I am going to discuss the classification of fuels, the characteristics of fuels, analysis of fuels, rather its coal under the proximate and the ultimate analysis. Then we are going to determine the calorific values using bomb calorimeter for the solid or the liquid fuels, and by using Dulong's formula, that is by the direct calculations. And lastly, we will discuss about the calculations of air needed for the combustion. Now these are the reference books, that is Engineering Chemistry by Jain and Jain, and Engineering Chemistry by Shashi Chawla, and Engineering Chemistry by Ville India, from where I have taken my references. The topics that I am going to cover today are the definition of the fuels, then the types of fuels, the properties of the fuels, then what is the calorific values of the fuels, and Dulong's formula. Now coming to fuels. Now fuels are nothing but they are the combustible substances which on burning in air they produce large amount of heat that can be used economically for domestic or industrial purposes. And the fuel is a substance which contains carbon as the main substituent, which provides energy on combustion for again industry or the domestic purposes. Now the combustion, it is a process of oxidation which provides heat energy. Every combustion is an oxidation, but every oxidation is not combustion. For example, combustion of wood, burning of wood, petrol and kerosene, they give out heat energy. Now coming to the classification of fuels. Now these fuels, they can be classified on two factors. First is the occurrence and how they are prepared, and the second is the state of aggregation. So on the basis of the occurrence, these fuels, they can be divided into two types, that is the primary fuels and the secondary fuels. Now primary fuels are those which occur naturally, which are present in nature, just like coal or crude petroleum, and also the natural gas. Now the coal and the crude petroleum, they are formed from the organic matter which was buried many years ago, and they are referred to as fossil fuels. And secondary fuels, these are those fuels which are derived from the naturally occurring fuels by different processes or the treatments given, and they are example coke, gasoline, coal gas, producer gas, blast furnace gas, etc. So they all are secondary fuel. They are formed from the primary ones, which are the naturally occurring in nature. Now the second classification, it is based upon their state of aggregation. So on the basis of aggregation, these fuels, they can be classified into solid fuels, liquid fuels and gaseous fuel. Now coming to the solid fuels, they can be natural or primary fuels like wood, then peat, lignite, bituminous coal, anthracite coal, and the artificial ones or the secondary fuels are the charcoal and the coke. Similarly, liquid fuels, the natural ones are the crude oil which is present, and the artificial or the secondary fuels are petrol, diesel and different fractions of petroleum which are formed. The third one, the gaseous, the natural one is the natural gas, and the artificial ones are the coal gas, biogas, oil gas, water gas which are being formed. Now coming to the characteristics of a good fuel. Coming first to the high calorific value. Now calorific value is nothing the amount of heat which is given out by 1 gram, burning of 1 gram of fuel is its calorific value. So when we burn the fuel, its calorific value should be high. That means small amount of fuel should also be able to give good amount of energy, useful energy which can be utilized. Then second, it should have moderate ignition temperature. Now ignition temperature is the minimum temperature at which a fuel starts burning. So by saying it should have moderate ignition temperature, that means we should provide some heat to the fuel and then it should start burning, and once it has started burning, then the entire fuel should burn. If this ignition temperature is going to be low, then in summers the fuel can automatically catch fire. And if this ignition temperature is going to be high, then we have to give a lot of input of energy so that the fuel, we can initiate the process of combustion in the fuel. Then next, it should have low moisture content. Low moisture content because if moisture is present in large quantities in fuel, obviously it is going to affect the burning efficiency of fuel. And in case of solid fuels, the matter which is left out after burning, that matter is going to be high. Next, low non-combustible matter content. Again, non-combustible matter content, if it is high, then it is going to affect the calorific value of the fuel. So this non-combustible matter content should be low in the fuel. It should have moderate rate of combustion. Moderate rate of combustion, that means once the fuel start burning, then that fuel should burn at a same rate for a longer period of time. If the fuel is burning at high rate of combustion, then automatically once the combustion process is initiated, entire fuel will burn quickly and lot of heat is going to get wasted. And slow burning, again, we will not be able to get the useful heat from the fuel. So in order to utilize maximum utilization of the heat energy from the fuel, the rate of combustion should be moderate. Then it should have minimum smoke and non-poisonous gases. Obviously, more smoke, that means more amount of smoke, then lesser is going to be the calorific value, and obviously poisonous gases should be less, like hydrogen sulfide, etc. The fuel should be cheap enough so that everyone can use. It should be easy to transport from one place to another. Then the combustion process that we are running, it should be controllable. That means once we want our fuel to stop burning, then we have the control at the combustion process. Then non-spontaneous combustion and low storage cost. Now coming to the characteristic property of a fuel and how these solid, liquid and gases, they depend upon these properties of the fuel. For example, first I am taking the cost. Now if I am taking the example of coal, crude oil and coal gas, then the cost, if I see the cost, then the solid fuel, coal is a cheap fuel, whereas crude oil is costlier than the solid fuels, and obviously gaseous fuels are costly. Storage, in terms of storage, solid fuels are easy to store. If I have coal or wood, I can put it at any place and I can store them. But in case of liquid and gaseous fuels, they ought to be stored in the containers. And for the gaseous fuel, those containers should specifically be leak proof. Risk towards fire hazard, solid fuels are pose less risk towards the fire hazards, liquid fuels are more, and gaseous fuels are highly inflammable. Rate of combustion, in terms of rate of combustion, combustion of solid fuels is a slow process, whereas liquid is fast, and gaseous, again, it is very rapid and fast process. Combustion control, once I start burning coal or wood, this process cannot be controlled unless and until the entire wood or coal gets burned down. Now this liquid fuels, they cannot be controlled or stopped when necessary. They can be controlled. And gaseous fuel, again, they can be controlled by regulating the supply. So, liquid and gaseous fuel, they can be controlled. Handling cost. The handling cost of solid fuel is high, whereas of liquid and gaseous fuel is low. Similarly, the ash problem, that is the part of the fuel which is left after burning. Obviously, ash is formed in the case of solid fuels, whereas on burning of liquid and gaseous fuel, there is no production of ash. Smoke. Solid fuels, they produce smoke, whereas the liquids, they are considered as clean fuels, but if they contain aromatic compounds, then obviously they produce smoke. And in the case of the gaseous fuel, smoke is not produced. In terms of calorific value, the highest calorific value is of the gaseous fuel. And again, in the terms of heat efficiency, again solid are least, whereas the gases have the highest efficiency. Now, coming to the calorific value, what we mean by calorific value. Now, the calorific value of a fuel, it is defined as the quantity of heat which is expressed in calories or kilocalories liberated by the complete burning of unit weight 1 gram or 1 kilogram of the fuel in air or oxygen, with subsequent cooling of the products of combustion to the initial temperature of the fuel. That means the amount of heat liberated by the fuel if we burn a unit mass of fuel is burned, and it is calculated in either calories or kilocalories. Now, we have different units for the calorific value. In terms of calories is defined as the energy needed to raise the temperature of 1 gram of water through 1 degree centigrade, and generally it is 4.1868 joules. Kilocalories, it is a unit of energy of 1000 calories. Then we have British thermal unit, which is also represented as in the short form as BTU. It is a traditional unit of energy equal to about 1055 joules, and it is the amount of energy needed to cool or heat 1 pound of water by 1 degree Fahrenheit. And this 1 British thermal unit, it is equal to 252 calories, or it is equal to 0.252 kilocalories. Then next we have the centigrade heat unit. This CHU, it is the quantity of heat required to raise the temperature of 1 pound of water through 1 degree centigrade, and 1 kilocalories is equal to 3.968 British thermal unit, and it is also equal to 2.2 centigrade heat unit. And if we need the interconversion of various units, then 1 kilocalories is equal to 1000 calories, which is equal to 3.968 British thermal unit, and it is equal to 2.2 centigrade heat unit. And 1 British thermal unit is equal to 252 calories. Now, coming to the gross and the calorific value. We have two types of calorific values which we determine in the fuel. One is the higher calorific value and the another is the lower calorific value. Now, this higher calorific value, it is also known as the gross calorific value, and the lower calorific value is known as the net calorific value. Now, coming to the definitions, this gross calorific value, GCV, it is the quantity of heat liberated by the complete combustion of unit weight of the fuel with subsequent cooling of the products of combustion to the initial temperature of the fuel. Now, this gross calorific value, it is determined in the different experiments. For example, if I determine the calorific value in our calorific value meter, then it is we can calculate. For example, like bomb calorimeter. If I am going to determine the calorific value in bomb calorimeter, then I am doing my heating process and doing the calculation in the closed environment. So, when I burn the fuel, and fuel after burning, the products, they are going to cool down in the bomb calorimeter, and the latent heat of combustion of steam, the water, it is also going to get included in the calorific value. So, the products of combustion, they are going to get cooled down, and their latent heat is also going to get counted in the calorific value. But in the normal conditions, what we do, water vapor, it is produced during combustion. Since hydrogen is present in all the fuels, so during the combustion process, this hydrogen gets converted into water vapor, and during the combustion, this water vapor, it is not condensed, and it escapes along with the hot combustible gases. If I burn wood in the open, I am not condensing any water vapor. This water vapor escape along with the hot combustible gases. Therefore, the calculation of calorific value that I am doing, it is of lesser amount. So, hence lesser amount of heat is available, which is called as lower or net calorific value. So, the net calorific value is the heat produced when unit mass of fuel is burnt completely and the products of combustion are allowed to escape. Now, the calorific value of a fuel, it depends upon the nature of the fuel and the relative proportions of the element present. We can do the theoretical calculation of the calorific value also by using Dulong's formula. And if for a fuel which contains carbon, hydrogen, oxygen and sulfur, the calorific value of the fuel, it can be given by Dulong's formula. If both hydrogen and oxygen, they are present, it is assumed that all the oxygen are already combined with 1/8 of its weight of hydrogen to form water. That means the oxygen combines with hydrogen to form water. So, the hydrogen which is available for combustion, it is going to be the total hydrogen which is present in the fuel minus the fixed hydrogen which has combined with the oxygen. That hydrogen is the fixed hydrogen. Therefore, this fraction is then deducted from the hydrogen content of the fuel in the calculation. For example, generally I have said that fuels, they all contain carbon. If there is carbon, hydrogen is also going to be present, and if oxygen is also present in the fuel, then this oxygen is going to be present in a combined form with the hydrogen. If my fuel, suppose it contains, if my fuel contains 10 atoms of oxygen and it contains, I am just taking for example 15 atoms of hydrogen, then this entire, or rather I say 25, then this entire oxygen which is present, it is going to be present in the combined form with hydrogen, and according to this formula H2O, then this oxygen will combine with hydrogen, and the remaining hydrogen which is left out after combining with oxygen, only that hydrogen is going to be available for the combustion process. Now, coming to the determination of calorific value from Dulong's formula, the Dulong formula is given as 1/100, 8080 percentage of carbon plus 34,500 percentage of hydrogen minus percentage of oxygen divided by 8 plus 2240 sulfur, percentage of sulfur, and it is calculated as kilocalories per kg or calories per gram. Now, here I have already discussed, but this carbon, hydrogen, oxygen and sulfur, they refer to as the percentages of carbon, hydrogen, oxygen and sulfur which are present in the fuel. Now, calculation of the net calorific value. How we calculate the net calorific value? I have already said that the hydrogen which is present in the fuel, it reacts with oxygen to give water. Now according to this equation, H2 plus half O2 gives water. 2H, they are reacting with half O2 to form water. You can say 2 parts of hydrogen they are equal to 16 parts and forming 18 parts of water. So 2 parts of hydrogen are combining with 16 parts of oxygen to form 18 parts of water. Or rather we can say 1 part of hydrogen is combining with 8 parts of oxygen to form 9 parts of water. Now let hydrogen is the percentage, capital H is the percentage of hydrogen in the fuel. So the percentage of hydrogen is given by capital H, and the amount of water which is being produced by burning the unit mass of fuel, it will be equal to 9H divided by 100 gram. That means it is the amount of water. 1 parts reacts with 18 parts to produce 9 parts of water. So the amount of water produced by burning unit mass of the fuel will be equal to 9 into H divided by 100 grams. And we all know that the latent heat of steam is equal to 587 calories per gram. Therefore, the amount of heat produced by the condensation of steam will be equal to 9H divided by 100 multiplied by 587 calories. So this is the amount of heat which is being produced by the condensation of steam. Now, the net calorific value or the LCV, lower calorific value, it is given as gross or the higher calorific value minus 9H divided by 100